And although our table of values from example 1 is always a great strategy, and you should never forget it, and if you're ever stuck, just start doing some table of values. It will be an awesome thing to use on any test or quiz, but there's always a better technique. And the main technique that we're going to use for grade 12 is, we're going to use the end behavior and all x and y intercepts. We have all of the x and y intercepts and the end behavior. We are going to get a pretty accurate graph. Now, in order to find a y-intercept, that's super easy. In order to find the end behavior, that's super easy. So in this question here, sketch this graph. First of all, just so that it's listed, if I started with my end behavior, I know that it's an x cubed graph, which is odd. I know that my leading coefficient is positive, so it's going to act like a positive line. There's my end behavior. Okay? Next, y-intercept is super easy because all you do is plug in 0 for x. 0 plus 0 minus 0 is 0. Your x-intercepts are what is going to be tricky. This example is extremely easy. We are going to do the second example in the textbook as well because it's a little bit harder. How do you find an x-intercept? Well, you plug in 0 for y. So if I plug in 0 for y, I get this. And now I have to solve. And the way that we solve equations is by factoring. And that's what this unit has been about, is factoring things. But this one is extra easy. This could have been a question from grade 11, not grade 12, because do you see that there's a common factor of x? And if I factor that common factor of x out to begin with, I'm left with a quadratic. Also fairly easy to factor. It's going to be x plus 3, x minus 2. So your x-intercepts are 0, minus 3, and 2. We can write them out. Well, 0 is 0, 0. We'd have minus 3, comma 0, and 2, comma 0. So we find our x-intercepts, our y-intercepts, and our end behavior, and look how good of a graph we can draw. Our y-intercept, 0, 0. X-intercepts, negative 3, 0, and 2, 0. Again, if you draw anything on a graph, you need to have something that labels your x-intercept, something that labels your y-intercept. And once you have all of your x-intercepts and y-intercepts labeled, and you know the end behavior, I know that it has to end down here and up here. Now it's just a matter of drawing a smooth curve through those points. The one thing that we won't have accurate for grade 12 is we won't have our maxes, local max and local min accurate. This point right here is just an estimate. It may be way higher. It may be a little bit lower. Same thing with this point. I don't know exactly. I could plug in some values to guess with the table of values, but for this course, they're happy with that as an estimate. They're like, we've got our x-intercepts, we've got our arrowheads, we have the general shape. This is good enough. We've got a sense of what this graph looks like. This question is not the greatest example. We're going to go back and do this one together. You don't have to write anything down because it's in your textbook. But we're going to go through the same steps. First of all, the end behavior of this one. It's an x to the 4, which a positive x to the 4, it acts like a parabola. That would be your end behavior. Y-intercept, super easy. Plug in 0 for x, 0 minus 0 minus 0 plus 0 minus 6 will give us negative 6. The x-intercepts are what are a little bit more difficult, so we would plug this in. And I might write above here, go let P of x equal all of this. And we have to use the factor theorem, the remainder theorem, and synthetic division to factor this completely. So, remember, first of all, the possible factors could be things that multiply to give you 6. So that would be 1 and 6, or 2 and 3. And it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. You could try one and see if it works. Sometimes you try one and it doesn't work. But in this example, we're going to just happen to guess the right one right away. Say, oh, I'm going to try one. So I bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add, and wonderfully I get a remainder of 0. So what have I done? I have started to factor this. I have 0 equals, so I would write 0 equals again. One factor is x minus 1. And then I'm left with 2x cubed plus x squared minus 13x plus 6. And I would do synthetic division again with the 2, the 1, the negative 13, and the 6. And now the last number is still 6, so it could be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. I'm going to cheat and use the textbook and say, hey, I want to try 2 first. But this could take a little bit of time, right? Sometimes you try something, it doesn't work. What's the worst is when you try something that should work, but you make a mental math mistake and it doesn't work, and then you spend the next half an hour searching for something else when you should have found it already. That sometimes happens. So we take our time in this part, bring down the 2, multiply, add, multiply, add, multiply, add. Once again, we get a remainder of 0. So now I can rewrite this, but instead of writing the 2x cubed now, I found out that one of the factors is x minus 2, and I'm left with 2x squared plus 5x minus 3. Once you get to a parabola, then you can just factor directly. It's going to be outside plus 6 minus 1 gives me plus 5. And now we have all 4 x-intercepts. X equals 1, x equals 2, x equals 1/2, and x equals negative 3. 1 comma 0, 2 comma 0, 1/2 comma 0, and negative 3 comma 0. So to graph this, what we need to do is we need to put on all of our x-intercepts. So we have an x-intercept at 1/2, at 1, at 2, and at negative 3. We have our y-intercept at negative 6. So again, I need to do some labeling on here so that you know what your scale of your graph is. Do we know the end behavior? Yes. The end behavior on this one has to start up here and has to end up here. So once you have all of your intercepts and the end behavior, now you're just going to draw a curve, a smooth curve, through all of those points. So if I start up here, now, maybe one thing I would do, like, we don't know where our maxes and mins are, but I wouldn't necessarily just connect these 2 points. Because just, if I want to draw it smooth, I think that minimum probably has to go way lower than that. 0, -6, sort of in between here. I'm thinking, well, the minimum's got to be somewhere in between those points. It's not perfectly in between, but it's close. Draw a smooth curve, no sharp lines. This is a fairly accurate graph of the equation. Even though it took us some time, it's much more accurate than a table of values, unless you did a lot of points on your table of values. And table of values can get annoying. Long division and synthetic division and factoring, a little bit annoying, I'll give it that. Takes some time, but once you have all of your x-intercepts and your y-intercepts, your graph is fairly accurate. Questions 7 and 13.